Okay, so earlier when we talked about the different ways of solving, rewriting, looking inside, and undoing, I mentioned that to use looking inside, we often used that for exponents, and today's the day. So in 333, we are going to solve mainly exponential functions or exponential equations where the look inside method is going to be the way to go. So I want to skip right down to the examples in 133 because you can read the top half of this page in the filled in notes. So let's talk about the action. The action happens when you look at a left side of an equation and a right side of the equation, and they already have the same base or they could have the same base. So for example, these both have a base of 2, meaning that in order for them to be equal, their exponents have to be equal. So look inside the exponent and say x plus 3 must have to equal 2x and solve that equation. Don't try to raise 2 to a power of x plus 3. I don't even know what that means. So we're going to solve the look inside method that the exponent inside these parentheses has to be equal to this exponent because they share the same base. So I'm going to subtract x from the left and subtract x from the right and get that 3 equals x or x equals 3 and be done with it. That's it. Now, if they do not come with bases that are already equal, you have to look at strategies for making them equal. For example, I know that 9 can be rewritten as 3 squared, and the left side has a base of 3. So 3 to the 5th equals, I'm going to say instead of 9, I'm going to think of 9 as 3 squared, still raised to the 2x power. And when I do that, I have to then combine those exponents, the 2 and the 2x, and think of it as 5 equals 2 times 2x. Now that they have base 3 that's the same, the exponent 5 has to be equal to the 2 times 2x exponents on the other 3. So 5 equals 4x, and you can divide both sides by 4, and you can get 1.25 equals x, or x equals 1.25. Heck, if you want to leave it as 5/4, you can do that as well. Now this one, the bases are already the same, which is great. I'm going to look inside the exponents. That means that 2x plus 1 has to equal the other exponent 3. I can solve by subtracting 1 on each side and get 2x equals 2 and divide by 2 for x equals 1. If you were asked what were the original exponents, you could plug that 1 back in and say 2 times 1 is 2 plus 1, and that would work because 2 plus 1 is 3. 3 to the third does in fact equal 3 to the third. The fourth example here, 8 to the 70th and 2 to the x, do not have the same base, but 8 can be written as 2 to the third. 2 times 2 times 2 is worth 8. So 2 to the third raised to the 70th power has to equal 2 to the x. So now that they have the same base 2, 3 times 70 in the exponents on the left have to be equal to the x exponent on the right, which means 210 equals x, or x equals 210. Now you could check that on a calculator. You could say, does 8 to the 70th equal x to the 210th? My guess is your calculator is going to give you an error because that's too many digits to show 2 to the 210th power or 8 to the 70th power. All three methods. So how do we determine what method to use? We sort of need to look at the 4 things that we've already sort of collected: the rewriting, the looking inside, the undoing, and then also the fraction busters, and say, what's the best way to attack each individual problem? This one, you'll notice, has a set of parentheses multiplied by another set of parentheses, or a binomial times a binomial. That screams rewriting to me because I'm thinking of the distributive property. So I would say I'm going to rewrite this one. I'm going to distribute the right side. There's nothing to do on the left side yet. You could add them together in this step, I suppose. 4x times 3x is 12x squared, plus 4x minus 3 would be plus a negative 12x. 8 times 3x would be plus 24x, and then 8 times the minus 3 would be plus a negative 24. I can start simplifying. The 11x and the x squared is 12x squared. Combining the x squared terms on the left, I'm going to have a 12x squared. I've got minus 12x and plus 24x. When I combine that is a positive 12x. And then the minus 24, which I can't combine with anything, but it's still got to be written down. If I take away 12x squared from both sides, they cancel each other, and all you have left over here on the left side is 0. 12x squared, take away 12x squared is 0. So now 0 equals 12x minus 24. That is still a two-step equation, even with a 0 over there on the left. I can add 24 to both sides. 24 equals 12x, and I can divide both sides by the 12 and get 2 equals x, or the better order, x equals 2. That was a rewrite. I couldn't undo. I couldn't divide both sides by a number. There were no fractions. There were no excessive decimals, no extra zeros, no exponents. So that was a clear rewrite situation. I'd like to think the next one is just as clear because it has fractions, that fraction busters is probably the way to go. So the least common multiple for denominators 3 and 9 would be 9. So I'm going to multiply everything on the left by 9 and multiply everything on the right by 9. So this 9 and 3 would simplify, and you'd have 3 left in the numerator for 3x. This 9 would cancel with the 9 in the denominator, so minus x, equals, and 6 times 9 is 54. 3x take away x, I would simplify on the left as 2x equals 54. And when I divide both sides by 2, x equals 27. And we said this was definitely fraction busters, not Facebook. Last but not least in this section, we have powers, exponents. And because they don't have the same base, but I can turn 36 into 6 squared, 6 to the x plus 9. 36 is 6 squared, still raised to the x power. Now they both have a base of 6. I've got x plus 9 on the left and the 2x on the right because of the 2 exponents. A 2 raised to an x is a 2x. And that's an exponent raised to another exponent. I'm going to subtract x from both sides. 9 equals x, or x equals 9. And most people would call this the look inside method as your best option because there are variables in both exponents. All right, if we flip this over to look at the back, there are some more examples as well as methods and meanings math notes section that you may peruse regarding the 3 methods and the fraction busters as well. All right, so D has fractions, which again leads me to believe fraction busters is the way to go. The least common multiple, I've got a 9, an x, and a 3. Clearly, it's got to have x in it. And 9 and 3, the least common multiple is 9. So I'm going to multiply everything on the left by 9x and everything on the right by 9x. And that's the fastest way. You could multiply by x and then in a second step multiply by 9. That would work as well. So I am going to say 9x, the 9s will cancel, leaving us with a 4 and an x in the numerator. 9x, the x's will cancel, leaving us with a 9 and a 1 in the numerator. The 9 and the 3 will simplify, and you'll have 2 times 3x, which is 6x. And you've gotten to the point where you've got a very straightforward equation to solve. I would subtract 9. Nope, I would not do that because I've got x's on both sides. So I would subtract 4x from both sides. 9 equals 2x, and divide both sides by 2. Now, the original problem had fractions, so you're not going to say 4.5. Because there were fractions, you're either going to leave it as 9 halves or you're going to go 4.5 equals x. X equals 4.5. Not going to go with a decimal answer because the original question had fractions. You stay with fractions. Now, this one is interesting. We haven't really talked much about this, but we do have to get rid of the square root symbol first. It acts kind of like parentheses. So when you're thinking about order of operations, I can't do anything else until I get rid of that over the x plus 3. And the inverse of square rooting is squaring. So I'm actually going to square both sides and say x plus 3 has to equal 36. Another way to look at this is the look inside method. The only thing that x plus 3 could be worth is 36 because the square root of 36 will give us 6 as an answer. So if I look inside, x plus 3 has to be worth 36. That's another way of looking at the question with the look inside method. So then I would just subtract 3 from both sides and get that x is 33. The next one, F, that one's got your extra decimals. Notice I've got a tenths tenths, and tenths. So I'm going to multiply everything on the left side by 10, multiply everything on the right side by 10, get 12x minus 2, right? Because I'm just moving the decimal point over one place, equals 38 plus 10x, which loses all of the decimals. Another option, you could start with rewrite if you don't mind things in the tenths. That's another option. I'm going to add 2 to both sides, get 12x equals 40 plus 10x, subtract the 10x from both sides, 2x equals 40, and divide by 2, x equals 20. If you had left all of your decimals, you still would have gotten x equals 20 as your final answer, because it is an equivalent equation. Last but not least, I would definitely use the look inside method and say, the only way for me to get something squared equals 9 is for the something to be 3 or -3, because 3 squared will give me 9 and -3 will give me 9. Sorry, -3 squared will also give me 9. So this one actually has 2 solutions. I would have to do x plus 12 set equal to 3, and I would have to do x plus 12 set equal to -3. I'm going to say this one more time. The look inside number is 3. 3 squared will give me 9. The other look inside number is -3, because -3 times -3 will also give me +9. So I have to solve it twice. There are 2 answers. The +3 answer gives me x equals -9. And the other side, the -3 answer, gives me x equals -15. 2 possible solutions. 2 solutions. All right. And that one I used look inside. If you had chosen not to use the look inside method, you also could have taken the square root of the left side and the square root of the right side, remembering that the square root of 9 is plus or minus 3. And you would have said that x plus 12 has to equal plus or minus 3. And you still would have found your 2 solutions. Last question. Are there any values of x for the equations in the previous problem that will leave it undefined? In D, there is one issue because x is in the denominator. X cannot equal 0. That would be a problem. In E, the x plus 3 cannot be negative. So in E, x plus 3 can't be negative, because remember, we can't square root a negative. So x has got to stay greater than equal to values of -3. Because we could have 0, we could square root 0. We just can't have the thing under the square root symbol worth a negative, because we can't square root a negative with real numbers. All right, so probably questions, and hopefully you guys enjoy the video check-in, because I tried to make it a little fun anyway. So I will see you in class. Bye.